In this video, we're going to have a look at linear inequalities. Up to now, we've been working with equations where the left-hand side and right-hand side are equal. Now we're going to have a look at inequalities where the one side is bigger than the other one. For this, we're going to make use of inequality signs, the smaller than and bigger than signs. Let's have a look at the statement 5 is smaller than 7. This is true. If I now add 2 on both sides of this inequality, I will have 7 is smaller than 9, which is still true. Or I can subtract, let's say subtract 3 on both sides, and then I will have 4 is smaller than 6, and this is also still true. Even when I multiply by 2, I will have 8 is smaller than 12, and this is also true. But when I multiply by a negative value, by minus 2, I will have minus 16 is smaller than minus 24. This, however, is not true anymore. Minus 16 is bigger than minus 24. So here you need to see that when I multiply or divide by a negative value, the inequality sign should be swapped around to ensure that the statement is still true. Example 1. Solve x. In A, we have 4x should be bigger than minus 20. And to solve x, I'm going to divide both sides by 4. And that means we will get x should be bigger than minus 5. In B, we need to divide by minus 3. And we just heard that when dividing or multiplying with a negative value, the inequality sign should turn around. So we will have x is bigger than, instead of the original smaller than, minus 4. So what do these answers mean? In A, x can be anything bigger than minus 5. This means that if x is any value bigger than minus 5, this statement will be true. In video 2 of algebraic expressions, we had an in-depth look at number lines, interval notation, and set notation. You're welcome to have a look at that again. In A, we can indicate that it's not minus 5, so an open circle at minus 5, but anything bigger than that, so anything to the right of minus 5. Let's choose any of these possible values. So let's take 2. If I substitute x with 2, I will have the statement that 8 is bigger than minus 20, and this is true. But if I now choose a wrong value, something to the left of minus 5, so let's take minus 6. If I substitute that, I will have 4 times minus 6 is bigger than minus 20, but this is minus 24. Bigger than minus 20, which is not true. So here you can see that any number bigger than minus 5 will make this statement true. Example 2. Solve x and represent your answer on a number line. This time we also have a bracket in our inequality. So, as usual, we will start by simplifying the bracket. That will give us 5x minus 15 is smaller or equal to 2x plus 6. Next, we will get all our x's on one side. So 5x minus the 2x will give us 3x. And on the right, we will have 6 plus 15, and that is 21. Now we can divide both sides by 3. And because I'm dividing by a positive value, the inequality sign will stay the same. So our answer is x is smaller or equal to 7. On my number line at 7, I will have a solid dot to indicate that 7 is also an option for x, and to indicate everything smaller than that, it is to the left of 7. Then just a reminder of interval notation. This answer can also be indicated as x is an element of negative infinity to 7 with a block bracket at 7 because 7 is also included. Example 3. Again, we are asked to solve x and represent the answer on a number line. This time we have two inequality signs. This is an indication that x will lie in between two specific values. To solve x here, I will do the inverse operations in three separate sections. Firstly, I want to get rid of the minus 3, and to do that I will add 3. But now I have to add 3 in 3 different locations. This will give me minus 7 is smaller than 2x, which is smaller or equal to 10. Now we need to divide by 2. And again, this will be repeated everywhere. So we will have minus 7 over 2 is smaller than x, which is smaller or equal to 5. This is our final answer. So on my number line at minus 7 over 2 or minus 3.5, I will have an open circle and ensure that we know this is exactly minus 7 over 2. And then at 5, I will have a solid dot to indicate that 5 is also part of the answer. And then I will connect these two dots to indicate that x can be any value in between.